Hey, and welcome back to the lab. And today here, straight from a contest auto event, we have a Yaesu FT857. And there was a heavy static charge. And the owner saw that really a thunderstorm comes up, and he saw that it gets dark. And then he thought, it's better if I go back into the car. And then he recognized already that the static charge was that heavy that when he was touching the radio, which of course he took with him into the car, but the antenna was still connected. And then when he was finally touching the radio, he recognized that really he can draw little sparks. And then he was really shocked a little bit, put it aside, and when the weather were getting better, then he of course tried if the radio still works, and he connected back to the battery, and he recognized that the radio came up, but then maybe 3 seconds later it dropped down, and he was not able to get it really back working. And now it is still in the same condition, so if you put it back to the power supply, it comes up, but then 3 seconds later it goes down. So that is really something interesting, and well, you know, that really can be anything in the radio, and the most critical thing is most likely that something is wrong with our CPU or such. So therefore that might be really an interesting one, and let's look into that, and let's see if we can help, because you know that is not always possible with faults like this. Alright, and here's already the radio, everything is prepared, so power supply is waiting, so let's try. So we connect it. And we see it comes up and then it goes down. And we cannot start it here over our button, but let's try once again. And that is interesting. So we see that it is operative when it is working for that short while. It is really operating, so we hear that we have the static in the speaker and such, but it will not stay on, so it really goes down. So very interesting to see is the fact that now where the radio is completely switched off, we still have 38 milliamps, which is used here by the radio, and I think that is a minimum at 30 milliamps too high. So in this situation, when the radio is off and connected to a power supply, you see 3, maybe 6 milliamps, and 38 is definitely too much. But on the other hand, when it fires up, 680 is not too bad. So that is the normal RX power which the radio draws, plus minus, I don't know, a little bit, but that looks good. So yes, we definitely have this fault, And let's see what we can do. So we need to crack it open. Maybe we can see something obvious, and then we really have to go step by step. Okay, we start here at our PA board, simply since we get here our power supply over our PA board into the radio. And well, I really have looked around, but there is definitely nothing obvious. I mean, here we have our power relay, which switches in, and here our filtering, and here is our first voltage regulator. And but other than that, I mean, there is nothing burned or abnormal or whatever. And then I flip it over, so that here is of course our main board. And yeah, on the main board everything looks fine as well, so no problem. So here is our processor, which gives me a bit headaches. So that is something we really need to check, because this switch on fire up procedure is a little bit tricky. So there are happening many things simultaneously, and well, if we do not find anything obvious, we really need to go through this firing up procedure and go step by step and check if everything works fine. So, well, on both PCBs nothing to see, but it is a double-sided PCB, so yeah, especially here on our main board with our CPU, there are components underneath which are involved in our firing up process. So that means I believe we need to get here our mainboard off to look underneath. But before we do that, we can do some testing here around our power switch, and then yeah, let's see what we can find. Okay, so to get a rough idea what we need to do, so we have our block diagram here, and of course we start at our PIA unit, simply because our power supply gets in here. So here we get our 13.8 volt in, and we have here a protection circuit which we are gonna check. Here is our power switch, so that is mainly the relay. Then we have here our first voltage regulator, which is very, very important. And then you see here a power on information, which comes from the controller, so from the CPU, which gives us a high level to switch, and we deep a little bit more into that later, which will switch a digital transistor, which then afterwards will switch here our relay, and then we get our power connected to all components in the radio, if you will. Then secondly, on the main unit, what we need to look after are here these voltage regulators. So you see that we have here an 8 volt regulator, another 5 volt regulator, and then we have something like our TX voltage and RX voltage, which mainly comes over our 8 volt regulator, but get switched by our CPU for RX and TX, of course. And then we have here another 3-volt regulator, so that is important. After we have here a discharge situation in the radio. So therefore that is something we need to check, and therefore we start here at the PA unit. And I know that is really confusing here, but when we zoom in, it gets all a bit more clear and more easy to understand. So mainly what we have here is our input from our external DC power supply, a filter here, and then we have here our relay, what we need to check, and we have here our Bose digital transistors. So that will be the first what we're gonna check, because this little digital transistor really gets our signal from the CPU that the radio will or have to switch on. So we get here an high, then this transistor will switch, and then you can see that the relay, which gets supplied here directly from our external power supply, okay, so you can see it here, that is a coil, and the little digital transistor will switch it through. And the interesting thing here is that at this transistor we will have finally already our CPU signal. So when or if we get, or the CPU gets the information switch on, then there will be a dedicated pin at our CPU which goes to high level, means 5 volt, and will then switch this transistor. And then we have here an overvoltage protection, so you can see it here. So if we are getting much too high voltage here to the radio, then this little Zener diode will break through, and you see that then this digital transistor will switch. And that means if you look here to that point, okay, this here is our CPU high level, and the high level from the CPU will be pulled down to ground, and that means that then subsequently our relay gets switched off. And that is really important, that the radio under too high voltage conditions will not get the high voltages to all the components, which of course many of those components would get destroyed. So that is important. And additional to that, here our regulator, which is important here for our circuit as well, because we get here a lot of components directly connected to this 5-volt regulator, and therefore that will be our first steps to see what's going on here. And of course down here we have our first components where we need to test. So we have here of course our digital transistors, and we have the transistor which switches here our relay. We have our Zener diode down here. So that of course will be the first what we do, and therefore let me prepare that you can see the voltmeter, and then we go ahead. Okay, so we can see here a little bit, and as already discussed, we are testing now the supply voltage at our diode here, which yeah, there we have our 13.7 volt, so that is fine. And now what we gonna check is when I start the radio, we go to our little digital transistor, and we go to its base, which should be here, I believe. And of course, even our radio is connected to our power supply. We do not see nothing, and here we should see approximately 0.7 of a volt. Then the relay gets switched, so let's check it. And 0.79, so almost 0.8, which makes sense. So, and here's the little resistor in front of it, so that means at the other side we should see approximately 5 volt. No, we don't see nothing. And now it will not switch, so maybe let me try the button here. And what we have seen are the 4.8 volt, which is important to us because we know that is a high level coming from the CPU. So the CPU is giving out something, and what we and that is a good sign, because the CPU is doing at least something. And of course, the next what we want to know is if our relay is switching, and therefore we take here our 5 volt regulator, and at the input we should see 13.7 volt. So that is when this relay switches. Let's see. Oops. Let's see what's happening. Yeah, 13.6. So that is the supply voltage switched over the relay. That is fine. And now we can already test if our regulator works. Again, we start the radio. Yes, 5 volt. So that is here definitely not the problem. But that means that everything what we can test here is fine. So the Zener diode for the high voltage protection is definitely fine, because otherwise this pulse, this switching coming from the CPU would directly pull it to ground, and therefore I'm certain that that is not the problem. So we go now over to the main board, and let's see what we can do as next steps. Yeah, here on the main board we can of course test here our 8 volt regulator, which we have seen on the block diagram as the main voltage supply for many functions. And therefore let's do that first. If our 8 volt is fine, that means we are already one step further. Okay, so we should be able to see. Let's go to the test point here, and let's see when I now start the radio. Oops. Good idea would to put ground to our radio, because otherwise we cannot test it. Okay, once again. and let's test. 7.9 volt, so that is good that our 8 volt is present. And now we are already, you know, at the point where we need to check, or where we need to get here our board off to go underneath. First of all, we should then be able to check if something obvious is there, and on the other hand, then we need to get to the components which are involved in the firing up process. So therefore, I go now and take the board off, and then we go ahead. Right, and as I told you, we have to take off the board, so that is what we have done. And we need to go down here into the area where we have the switching process to switch finally the radio on and off. Well, but as we had it with some other videos as well, so alright, I have gotten here all the needed component to do the job here, but I'm already approximately 3 months older, because it really took a long time to get the needed components from Yaesu. So there you see we really have ship problem, delivery problems with ships and electronic components, and all our radio manufacturers are suffering from the same problem as everybody these days. So that is why we really have to wait such a long time to get our components. But now they are arrived, and we really can go into it, and let's start. It's a lot to do. And of course that we all know where we are. So of course this here is our processor, and then we have here our switching circuit. So all of this here is involved in the switching. So we have here our digital transistor, which is finally switching in over this component our voltage which is needed to supply finally our processor. And of course we have here as well our reset circuit which is needed, so you can see it here. So that is reset for our processor, and everything is really here involved in switching in and off. So, and remember, our radio suffered in a thunderstorm, so we really do not know which component really gets hit by the thunderstorm. So we really have to consider, or we even have to consider, that maybe we can not even really test for a faulty component, because it is really different if components really get hit by a thunderstorm, by an ESD pulse or such. So therefore, in this case, it's a good idea to really swap out all the critical parts, and that is what we are doing here. Now I start to put some fresh solder here to our components, that I will be able to get them out quite easily, and therefore that is now the first step. Okay, and everything is prepared, so now we take off all the old components to get ready for our new components. And so let's go ahead. Here you can now see that we have removed all the components involved here in our switching process, And so now we have to clean the board, and then we start to rebuild it. And here you see all the components which have been taken off, so that you get an impression what it is. And I can tell you that this voltage regulator here has a lot of ground plane right here on the board, and it is really difficult to get it off, so be careful if you try it for your own. Okay, so we are really making progress. So everything here in the switching process involved parts are rebuilt, so everything is new. And yeah, let's hope that it is not our processor which is making trouble as well. So let's hope and cross fingers that this now will solve our problem. Okay, so we really have replaced here in our 857 all the components which are involved in the switching process, so that means firing up the radio. And I can say that now all the values around our power supply inside the radio is now working fine, and all values are within the specifications. That is something we did not have before, so the voltage values were a little bit out, and now I can say that the complete power components are fine and working as they should. But nevertheless, we have still here a problem with the radio, and as you have really watched this video right from the beginning, you heard me saying that if you are if a radio was into a thunderstorm and get hurt, so you know, you never know what really happens inside the radio and which components are really hit finally. So now the assumption which I already had at the beginning, so I always said I hope that our MCU CPU does not get hurt by the thunderstorm. But you know, after I have now replaced all the components we have seen before, I truly believe that we have additional, really, and so sadly, a problem with the MCU as well. And so I have put here two 857 on the bench, as you can see, that we can compare it here a little bit. And both units are in standby, and you see here on the left hand side the power supply is supplying the radio what we are repairing and which was in the thunderstorm, and the other power supply is the radio which is reference, so which is totally working without any problem. And you see that we already have here a standby power difference. So that is what I also already mentioned at the beginning of this video, that the standby current is too high, and 38 milliamps, which our radio under repair is drawing, is definitely too high. And we see the other power supply with 3 milliamps. That is a current which is normal for radio under standby conditions. And therefore there must be a root cause why our radio, which was in the thunderstorm, are drawing so much current compared to what a fine unit is drawing. So therefore that led me to the idea, so let's see what thermal images is telling us, and let's compare it, and let's see if we might see a difference where we can conclude what might have happened. Okay, so let me try that we can see what's going on here. So we have down here our reference picture, and this is here our IR image, of course, and you see here that is our processor, our MCU, and here where we have our temperature cross, so there is our MCU, and you see in respect to the temperature of our MCU, you see it is cold entirely, so there is no hotspot, nothing, and it is under, as we said, under standby condition. And when I now go and fire the radio up, so let it switch in, and you see, of course, our MCU gets awake, and it has already fired up, and of course the MCU is developing some temperature, which is of course totally normal. And now when I switch it off again, so now it is off, you see slowly the temperature is decreasing again, and you see even that we have our standby current of 3 milliamps, what we have seen, it so the temperature is vanishing here. So that is how it really should look like. And now let me directly go over here to our faulty unit, and you can see it here right away. So the radio is of course in a standby condition, and what you easily can see here, that we have a hotspot. Yeah, so we have almost a temperature at our MCU, which our good radio is showing when we are firing up the radio. So that means we definitely have here a current leakage, and that means that we definitely have a problem with this MCU. And that is, but you know, the MCU is not totally toasted, because we've seen it when we tested the radio first. So it comes up for some seconds, and it is operative, so we have seen all that, but then it is switching down or off. And that is because there is a malfunction which is obviously only a portion of our MCU, but that is enough to produce our malfunction, which is showing up as that the radio can't stay on. So that means we really have to swap out our MCU here, and we only can hope that that is really the last component which really got hit by the thunderstorm, because as I said it at the beginning, and it is still the same, we never know what a thunderstorm can damage in a radio. And we get at a point where we really have to say, okay, it does not make any sense to go any further, because sometimes it really gets too expensive. But what we do, we go and swap out here our MCU, and we cross fingers and hope the best that we really can solve our problem here. Okay, so after we decided to replace the MCU, everything is prepared so far, and our new MCU has been delivered, so we can start to prepare here our MCU swap. Right, so what I just wanted to show you is that if we go closer here to our new MCU, you see the marking R1453, which is obviously the variant and the software version of this MCU. So what I just want to bring into your mind is that is always a little bit critical, because I have already experienced that even if I ordered MCU together with the serial number, which should then be clear that in this case Yaesu is able to figure out which MCU is the right one and which software is the right one, so that shouldn't be a problem in any way. But I have experienced that sometimes they deliver the wrong part and maybe with the wrong software, so that it don't really work. So therefore it is always a little risk that you really got the right one, but there is no other way. So as I said, I ordered the new MCU together with the serial number, and the only hope is that I really got the right one. So anyways, let's prepare to take, of course, the old one off, and then let's put the new one in. All right, and here we have our situation on the board. And the first what we need to do is to take this capacitor out, because simply I need the space here to drop here our new solder for the new chip, of course. So therefore we take this out, and a second step will then be to take the old chip out, prepare everything for the new one. So first step is now to prepare here our little capacitor, to get it out without any damage, because we definitely need the capacitor afterwards. So therefore very carefully. And first we put some fresh solder to the little cap. Okay. Yeah, looks good. Second side. And once again, we really have to be careful not to damage here something. And therefore we take now our tweezer and take it off. So, and you may not really realize here through our microscope how small and tiny the situation is down here. So once again, if you ever do a job like this, be careful, because you really can damage a lot. Another thing where I want to point your attention is once again here our orientation. So we have here the dot, which of course need to be the same with the new chip, because otherwise it wouldn't work. And now we prepare here our ship, because now we have, of course, the challenge to get it off. And the real challenge is to not damage here the board. And believe me, sometimes that is really no fun. So put enough of flux to it, and then let's see that we really can prepare for taking off. And for that, what I'm doing is to put some low melting solder to the ship, which is very helpful in for these tasks. And you see, I really try to put it everywhere. Okay. And of course I do it round to all pins. We have to do exactly the same, of course. And you see, even now our little capacitor would be in the way, so that was definitely a very good idea to take it off finally. So I hope that this now is already good. Let's see if it works. And of course now I have to take hot air, and I believe I increase a little bit the air flow. Maybe, yeah, so that sounds good. Let's see that we have here our fume extractor on. And now let's try to heat it up here. As I said, that is low melting solder, and you see that I was able to lift the old ship off without any problems, and that is very, very important. And you can see right away that we were really able to save all our pads. Now the next is I have to clean the pads to be able to prepare the new ship. Before we now clean the pads, it is quite important to remove a little bit the old and used flux, because you know that flux worked in a way that the chemical reaction has been taken part, and that means we need fresh flux to clean the board, and therefore it is always a good idea to do as a step in between cleaning the old and used flux off. And that is, as you can see, what I'm doing here. And just take your time to do it, because you should not rush, otherwise it is really no good idea. Okay, so I believe that could be okay. And then, of course, the next step is to put new flux to our pads. Right, and here you see me putting the new flags to the board. So we still have, of course, the low melting solder here on the pads. So that shouldn't be a big problem to get it off, but let's see how it turns out. Okay, so let's start. Whoops, doesn't want to. Oh, not too bad. As we can see, it is really the low melting solder which makes it here a little bit easier, and I guess you can see that it works quite nice. Okay. Okay, looks good. Yeah, I think that is fine. Okay, so here we have our cleaned pads, and as you can see, we don't have any damages so far, which is good. And now next is to fix our new processor to the pads that we then can solder in the whole ship as we need it. Okay, here is our new ship, and of course we have to positioning the new ship, and then we have to tack it to 2 points, and yeah, of course that is now a very critical process, and I really have to do it off camera. Sorry for that, but yeah, as I said, it really needs to be very, very precise to not have any problems afterwards. Okay, as you can see, we have here our new MCU in, and yeah, I have of course tested if there are bridges somewhere, and there are no bridges anywhere, and well, we have contact all around, and you see it looks pretty nice, so no problem at all. So the last what we have to do is to put back here finally our little capacitor, which we have taken out for the soldering process, and then yeah, we should be ready with the MCU replacement. And since that is not so critical, we can do that on camera. So let's see how we can arrange that. Okay, and of course we need to do the other side. Oop, where we are? Here we are. Okay, let's see. Put better a little bit fresh solder to the joint, like so. And now let's see if that will work out. Okay. Maybe a little bit additional solder, not much, just a micro drop or so. Okay, let's see. Yeah, that is perfect, I believe. And of course, as always, we have to clean it immediately. Yeah, that looks good. Fantastic. So that means job is done so far. Okay, so everything is back together, and yeah, finally we have to do our test. If that is coring our problem or not. So to be honest, I'm a little bit nervous, because it is always you'll never know. Okay. Anyways, it's fine so far. Everything is prepared. So first of all, let's change the camera view so that we can see our power supply, and then let's go. So we should be able to see everything. Okay, so first let me plug in our connector, and let's see what the reaction will be. Okay, let's try. Oh wow! Our standby current is, can you read it, is 3 milliamps. And remember, that is exactly what we have seen here with our reference unit. So we have seen that 3 milliamps is exactly what a good standby current will be. So that, to be honest, looks very promising. Okay, so let's go back. And okay, now we are at the point of truth. So let's see. Okay. Have a look. It is working. Okay, let me switch it back off, because let me connect the speaker to see if we have static. Okay, so you see I've connected here my test speaker, and now let's see if we got static here. Wow, so that is fine as well. So I can operate it everywhere, obviously. So that is really nice. Very good. Okay, so next step is let's connect a signal to it to see what will happen. But to be honest, you know, you never know. So it easily could have been some more ships which were gone, because a thunderstorm is definitely no joke. And well, finally we really need to put a signal to the radio to see what's happening with a signal. So that will be the next step now. Okay, and I put a signal to the radio, so you see we have the S meter giving us the indication, and when I increase here our volume, we really have a nice signal. So let me show that on the tester. So let me go over to there. Okay, so have a look. That is really nice. So let me turn down here the tone. So what we can say with an S9 signal, we have a fantastic signet, and you see the signal over there is really crisp and clean. But of course we are interested what finally our sensitivity will be, because that is telling us something about the radio. So therefore let's go down here and let's see how far we can go down, and let's go down, have a look. So already fantastic, already fantastic. So no doubt we are really back in business, as you can see. So that is definitely fantastic. Just playing here a little bit with the signal to see how it is reacting. But as you can see, without the front-end amplifier in, it is really an excellent sensitivity. So I would say it is really back to business. And of course I'm going to perform now some other tests, but I believe you would agree when we say it is really back to business. So the thunderstorm really hit our MCU and hit the internal power supply that both needed to get replaced, and we have done it. And we have an excellent success, because that is not always given with a radio which came, you know, from a thunderstorm. So yeah, I'm really happy that it is back working, because you know, the 857 is not or is not still on sales, because this radio is obsolete, and many operators really love the 857, and the person who owns this radio was really sad that that happened to his radio. And you know, because he was not able to buy a new 857, and now I'm happy that I'm able to give this nice radio back to him, and that he really can go outside on the hill for operating. Okay, thanks for watching, and catch you next time. Bye.